Select the best reagents to accomplish the following transformation. So we want to see what we're starting with and what we're ending up with as a product. So we are starting with an ester. And our product is also an ester, it just happens to be a different ester. So if you're going from one ester to another, then that means that you are performing a trans-esterification reaction. So you really want to think about how you could do this. So there's two sets of conditions that you could use for trans-esterification. So this could be done under either acidic conditions or under basic conditions. Neutral is not an option because your esters are not reactive. We need to kind of force these to react by using either acidic or basic solution. So you want to look at what the ester is that we're forming, and then this can allow us to identify what we would use. So if you are going to do this reaction under acidic conditions, then that means you would be adding this OR group, because this is essentially just an OR group, as the neutral alcohol. So you're going to put a hydrogen on there, and then you have a CH2 and this kind of isopropyl group. So CH2, right, in this group. And the way that you do this reaction under acidic conditions is you use the neutral alcohol, but you also have an acid catalyst. And heat. All right, these really, your esters are not very reactive, so you need both the catalyst and the additional energy in the form of heat. And if you were to do this reaction in basic conditions, then your nucleophile would be the alkoxide. So rather than being the neutral alcohol, you're going to take the hydrogen off of there and add it as the alkoxide. And then you typically have this with the alcohol as a solvent. So that allows you to generate more of that alkoxide. And another thing we're doing when we're using the alcohol in either one of these conditions, you're going to try to use that alcohol as the solvent because this is going to be equilibrium driven because you don't have a difference in your leaving group ability. So the reaction could essentially kind of go back and forth. So to push it to one side, you use an excess. So for the basic conditions, you're going to use the alkoxide, you're going to use the alcohol, and you're still going to need to heat that up. And so notice I drew out these reaction conditions and I haven't even looked at these possible products yet. So now that I know what I'm looking for, I'm going to see if I have either one of these sets of conditions down here. And so I can see if I'm comparing, B and D look like trans-esterification conditions because here you've got, an alkoxide and alcohol. You don't have heat, and you'd notice that's not the right alkoxide. It doesn't have the right bonding. If we look at D, we do have the alcohol that we're looking for, right? This is the same as our structure up here. Sulfuric acid is a common strong acid catalyst, and we are heating that up. So the right answer here is D. So I compared B and D because to me, looking at those are trans-esterification conditions. A might trip you up a bit because you do have acid, you do have heat, and you do have the right alcohol. But notice that these are two separate steps. So step one here, if you took your ester and it went through that reaction, H3O plus and heat, that's an acidic hydrolysis. So that would hydrolyze your ester and you would get the carboxylic acid. And then if you wanted to take your carboxylic acid and make an ester, you could, but you would need more than just the alcohol. Just the alcohol itself would not be enough. You would need that alcohol, right, CH2OH. So you'd need that alcohol, you'd need an acid catalyst, and you'd need heat again. And that would be what's known as your Fischer esterification. So this option A is kind of close, but things fall apart in the second step where you don't have the energy needed to go from the carboxylic acid back to an ester. So that's not going to work, even though it might at first glance look kind of close.